Hey there, science fans! Welcome to a place where the ordinary rules of reality get tossed out the window and the impossible becomes possible. Today, we're about to embark on an adventure into one of the most fascinating and mysterious areas of science, the quantum world. Get ready for a wild ride into the mind-blowing world of quantum mechanics. This is the science that explores the tiniest building blocks of our universe, particles so small, you could line up 1,000,000 of them across the width of a single human hair. It's a place where things aren't always as they seem. In fact, the deeper you look, the stranger things get. Light can act like both a wave and a particle, and objects can exist in multiple states at once. Tiny particles like electrons and photons play by a different set of rules that defy our everyday experience. They can vanish and reappear, tunnel through barriers, and even affect each other from vast distances away. These rules are strange, even bizarre. Imagine flipping a coin and having it land on both heads and tails at the same time, or seeing a cat that's both alive and not alive until you check on it. That's the kind of weirdness we're talking about. But don't worry, we'll explore them together. You don't need to be a genius or a physicist to appreciate the wonders of the quantum world. All you need is a sense of curiosity and a willingness to be amazed. Imagine a world where things can be in two places at once. This isn't just science fiction, it's a real phenomenon called superposition, and it's been proven in countless experiments. Or a world where particles talk to each other instantly, even across galaxies. This is called quantum entanglement, and it means that two particles can be connected in such a way that what happens to one instantly affects the other, no matter how far apart they are. And if you think that's wild, consider quantum tunneling, where particles can pass through barriers as if they were ghosts, appearing on the other side, without ever crossing the space in between. This is the crazy reality of quantum mechanics. It's a world where the rules are written in probabilities, not certainties, and where observation itself can change the outcome of an experiment. It's a realm so mind-bending that it challenges everything we thought we knew about the universe. Even the greatest scientists, like Albert Einstein, were baffled by its mysteries. The quantum world is full of mysteries. Some of its secrets are so strange they almost sound like magic, but they're real, and they're changing the way we understand reality itself. By understanding quantum mechanics, we can unlock some of the universe's biggest secrets. This knowledge is already leading to incredible new technologies, like quantum computers and ultra-secure communication systems. Imagine computers that can solve problems in seconds that would take today's fastest supercomputers millions of years, or networks that are impossible to hack. That's the power of quantum science. So buckle up, get ready to have your mind blown, and let's dive into the quantum realm. Together we'll discover a tiny world full of big surprises, where the impossible becomes possible and the future is being written right now. Okay, so what exactly is quantum mechanics? You might have heard the term thrown around in science documentaries or read about it in articles, but what does it really mean? Why do scientists get so excited and sometimes even baffled when they talk about it? Well, quantum mechanics is a branch of physics that deals with the tiniest building blocks of our universe. We're talking about things so small you can't see them with even the most powerful microscopes. Simply put, it's the study of how tiny particles behave. These particles include atoms, electrons, photons, and all the other minuscule components that make up everything around us. Quantum mechanics helps us understand how these particles move, interact, and even exist. Think of it as the rulebook for the microscopic world of atoms and the particles within them. Just like there are rules for playing a game, there are rules that govern how these tiny things behave. But here's the twist. The rules in the quantum world are nothing like the rules we're used to in our everyday lives. Now, in our everyday world, we use classical physics to describe how things work. This is the physics you probably learned in school: Newton's laws, gravity, and the way objects move and interact. A ball thrown in the air follows a predictable path. You can watch it arc gracefully, and you know exactly where it will land if you know how hard and at what angle it was thrown. We can calculate its speed and trajectory. With the right equations, we can predict its motion with incredible accuracy. This is the world of certainty and predictability. But in the quantum world, things get weird. The rules change completely. Suddenly, certainty is replaced by probability, and predictability gives way to strange behaviors that seem to defy common sense. Particles like electrons don't act like tiny balls. Instead, they behave in ways that are both fascinating and confusing. Sometimes they act like particles, and other times they act like waves. They're more like fuzzy clouds of possibilities. Instead of being in one place at one time, an electron can be spread out, existing in many places at once, at least until we try to measure it. Their location, speed, and energy are all uncertain. This is known as the uncertainty principle, and it means we can never know everything about a particle at the same time. It's like trying to hit a moving target that's also a wave. Imagine aiming at something that keeps shifting and spreading out, never staying still or solid. Quantum mechanics tries to make sense of this fuzziness. It gives us the mathematical tools and concepts to predict the likelihood of where a particle might be, how it might behave, and how it interacts with other particles. Even though it sounds strange, quantum mechanics is the foundation for much of modern technology, from computers to lasers to medical imaging. It's a rulebook that rewrites our understanding of reality at the smallest scales. One of the weirdest things about quantum mechanics is superposition. This means a particle can be in multiple states at the same time. Imagine being in New York and Los Angeles simultaneously. Sounds crazy, right? Think of a coin spinning in the air. Until it lands, it's both heads and tails at the same time. That's kind of like superposition. An electron can be in multiple energy levels or even different locations until we measure it. Once we measure the particle, it chooses a state. It's like the coin finally landing on heads or tails. This act of observation actually influences the outcome. To understand this further, let's talk about Schrödinger's cat. It's a famous thought experiment. Imagine a cat in a box with a device that has a 50-50 chance of releasing a deadly poison. Until we open the box, we don't know if the cat is alive or dead. According to quantum mechanics, the cat is both alive and dead at the same time. It's in a superposition of states. Of course, cats can't be both alive and dead. This thought experiment highlights how strange the rules of quantum mechanics are when applied to our everyday world. Hold on to your hats, because this next one is really wild. Quantum entanglement is like two particles having a telepathic connection. Imagine two coins flipping and always landing on the same side, even if they're miles apart. When two particles are entangled, they share a special bond. Measuring the state of one instantly determines the state of the other, no matter the distance between them. Einstein called this spooky action at a distance. Entanglement has huge implications. It could revolutionize communication and computing. Just imagine sending information instantly across the universe. Scientists are still unraveling the mysteries of entanglement. The quantum world is full of even more bizarre phenomena. When we zoom into the tiniest scales of reality, the rules we're used to simply break down. Here, things don't behave in ways that make sense to our everyday experience. Instead, we find a universe that's unpredictable, counterintuitive, and sometimes downright mind-bending. Let's take a quick look at a few more of these strange quantum effects that have puzzled and fascinated scientists for decades. Sometimes, what we think of as tiny particles like electrons or photons suddenly act like waves. In famous experiments, such as the double-slit experiment, a single electron can create a pattern of interference, as if it traveled through two places at once. This wave-like behavior is at the heart of quantum mechanics. But then in other situations, those same waves behave like individual particles, showing up as single distinct points on a detector. It's as if reality can't decide whether to be a wave or a particle until we look at it. Imagine if a baseball could suddenly spread out like a ripple in a pond, and then snap back to being a solid ball the moment you tried to catch it. That's the kind of weirdness we're talking about. Now picture a ball magically passing through a wall without breaking it or leaving a hole. In our everyday world, that's impossible. But in the quantum world, this is a real effect called tunneling. That's kind of like quantum tunneling, where particles can appear on the other side of barriers that, according to classical physics, they simply shouldn't be able to cross. This means that, at the quantum level, particles can borrow energy for a brief moment and slip through obstacles as if by magic. This isn't just a theoretical idea. Quantum tunneling is essential for processes like nuclear fusion in the sun, and even for the operation of some modern electronics. But the strangeness doesn't stop there. In the quantum world, we can never know both the exact position and momentum of a particle at the same time. This is called the Heisenberg uncertainty principle. The more precisely we measure a particle's position, the less we know about how fast it's moving, and vice versa. It's not just a limitation of our instruments, it's a fundamental property of nature itself. So, if we try to pin down exactly where a particle is, its speed becomes a blur of possibilities, and if we know its speed perfectly, its location becomes uncertain. These might sound strange, but they have real-world consequences. Quantum mechanics isn't just a set of weird rules for tiny things. It's the foundation for much of our modern technology. MRI machines, lasers, and even quantum computers all rely on these principles. And on a cosmic scale, quantum effects are crucial for understanding how stars shine, how elements are formed in the hearts of stars, and even how the universe itself began in the Big Bang. Even our own bodies depend on quantum mechanics. The chemistry that keeps us alive, the way our cells function, and the processes that allow us to see and think, all are governed by the strange, beautiful rules of the quantum world. Quantum mechanics isn't just theoretical, it's all around us. Many technologies we use rely on quantum phenomena. Those laser pointers you use, they wouldn't exist without the quantum behavior of light. The transistors that power our devices rely on the quantum properties of semiconductors. These medical marvels use powerful magnets and radio waves to manipulate the quantum spins of atoms in our bodies, creating detailed images. The fiber optic cables that bring the internet to your home, they use lasers which, as we know, are based on quantum mechanics. These are just a few examples of how quantum mechanics shapes our daily lives. We've only scratched the surface of the quantum world. There are still many mysteries to uncover. For example, how can we reconcile quantum mechanics with Einstein's theory of general relativity? Can we build quantum computers that revolutionize fields like medicine and material science? The quest to understand quantum mechanics is one of the most exciting scientific adventures of our time. Each new discovery brings us closer to unraveling the deepest secrets of the universe. It's a quest driven by curiosity, imagination, and the desire to push the boundaries of human knowledge. So there you have it, a glimpse into the weird and wonderful world of quantum mechanics. Remember, the universe is full of surprises, and the more we learn, the more we realize how much we don't know. Keep questioning, keep exploring, and never lose your sense of wonder. The future of quantum discovery is in your hands. Now go out there and explore the quantum universe. Stay curious.